It's that time of year again, winter. Love it or hate it, it sometimes brings us a little extra snow or a nasty cold snap. So every winter about this time, we hear another objection to the reality of climate change. And it goes a little like this. I looked outside and it was cold, therefore there is no climate change. Let's examine this little jewel of deductive reasoning. Here's what the national weather map from weather.com looked like on January 16, 2009, the deepest trough of the recent cold snap. The map is set up to show deviations from normal temperatures for this date, negative or positive. Sure enough, the eastern United States was blanketed by cold air with temperatures 10 and 20 degrees below normal. But take another look. It turns out the western United States was having unusual temperatures as well, but in the other direction, 10 and 20 degrees above normal. Now what can you say about global climate based on this slice of conflicting temperature data over 1.6% of the globe's surface area? Well, nothing, actually. Because we're not looking at climate here. We're looking at weather, which has a high degree of chaotic variability. So what would an indicator of climate change be? Well, let's take a look at another weather map, the kind that climatologists pay attention to. What you'll see is the NASA year-end summary for global surface temperatures in 2008. You'll see that it's color-coded to show the deviation from average temperatures in the base period from 1951 to 1980. Reds are warm, blues and greens are cold. What you immediately notice is that there's a whole lot of reds on the map, even dark reds. That's because in 2008, the planet was, as a whole, almost half a degree centigrade warmer than it was during the period from 1951 to 1980. And in some critical areas like the Arctic Ocean, Siberia, and the Antarctic Peninsula, it was a lot warmer, 2-3 degrees or more. Now that's the kind of data that indicates long-term change. That is climate. So, get it? Weather is not climate. So what causes all this variability year to year? Ocean surface temperature has a powerful impact on global temperatures because the heat that is held in ocean waters is far greater than that held in the air. The largest reservoir of global ocean heat is probably in the southwestern Pacific. Even a small change in ocean surface temps spills a huge amount of heat into the air. How that reservoir behaves is a matter that a lot of scientists are studying, because when it moves around, as it does on a 3 to 7 year cycle, it sometimes moves out from the western Pacific across the eastern Pacific and piles up against the coast of South America. We call it an El Nino. And the last time it happened, in the winter of 2007, cherry blossoms bloomed in Washington, D.C. in January. But the pendulum always swings, and El Nino has a twin. As the warm surface waters in the eastern Pacific dissipate, they are replaced by colder waters that suck tremendous amounts of heat out of the atmosphere. It tends to have a cooling effect on surface temperatures, precipitation, and weather events worldwide, and that is what we have had for the last year. And we call that La Nina. Now here's a graph of global surface temperatures since 1960. As you can see, the general direction of change has been sharply upward, but there are plenty of temporary ups and downs along the way. If we map the El Nino peaks and La Nina troughs onto this graph, what does it tell us? It's not hard to see that the El Nino cycle has a major impact on year-to-year variability across the globe. There are other factors, but this graph makes clear that this is a major one. One slice in particular, in 1991 and 92, it seems that global temperature stays cool even though there's a moderate El Nino in effect. What happened? Well, 1991 was, of course, the year of a gigantic volcanic eruption of Mount Pinatubo in the Philippines, which blasted an enormous amount of reflective particles into the atmosphere and lowered global temperatures by about a degree for a year or more. After that, the normal pattern quickly reasserted itself. So what's the best way to keep up with all these changes in global climate? Well, I have a philosophy about this, and generally it's that the smartest guy in the room is going to be the guy that works for NASA, the National Aeronautics and Space Administration. They are, after all, rocket scientists and our best experts on climate change. NASA's annual review of global temperatures for 2008 is now available, and it says 2008 is the 9th warmest year in the period of instrumental measurements, which extends back to 1880. And the 10 warmest years all occur within the 12-year period 1997 to 2008, and that El Niño and increasing greenhouse gases continue to be the dominant factors affecting temperature change. So set your crazy uncle straight. Tell him weather is not climate, and then he can find out what the real science says by coming back to Climate Denial Crock of the Week regularly. In coming weeks, I'll be crushing all the favorite denial crocks, and if you have a favorite crock you want cracked, let me know. Keep your comments and suggestions coming in, and let people know about climate change and what we have to do about it. Thanks a lot for listening.